You could throw any vocabulary, any facts. Don't look through the packet and be that kid. Any vocabulary or facts that you know about a circle before we start? Any parts of a circle, facts about a circle you want to throw out there before we begin? Or am I just starting with, I know nothing about a circle. Teach me, teach me, teach me. Matthew.
Well, I was going to say it measures 360 degrees.
360 degrees in a circle. Yep. Absolutely. Excellent. 360 degrees in every circle. Anything else? That's it, huh? This is why the unit's the toughest. You know, usually, like, let's be honest, the transformation unit, reflections, rotations, dilation, translations, you heard those in middle school before. You've heard a lot of the units we've done so far. You can say, oh, I've heard this before. I've heard this before. We're just taking it to a high school honors level. I think with circles, nothing. All right, nothing. Maybe a couple words, but that's about it. All right, so let's jump into this here. Let me start you here, guys. Let me start you here. Name that triangle. Why are you calling it ABC? Because that's the vertices, right? Those are the vertices. All right, gotcha, got you. Name that quadrilateral. WXY, why are you calling it WXYZ? Those are the vertices. Hi, I don't have vertices. How you name me now? Right? No vertices. So how do we name this? Will, you got an idea? We name a circle. There's your first thing for today is we name a circle by its center. Yes, we name a circle by its center. So this right here, we're going to call circle C, because C is the center. Notation that you'll only see in your textbook, I do not care for it, so I don't choose to use it. But in your textbook, they'll use this as a circle and then put C next to it. I do not like that notation, so I will not use it. Your textbook will, so circle C. All right, so that's how we name it. Let's talk about the three parts for today anyway I need you to be familiar with. You guys remember talking about a segment all year long, right? A segment has two endpoints. If those endpoints are on the circle, if we create a segment inside the circle and the endpoints are on the circle, so this segment right here where the endpoints are on the circle, we call this a chord. C-H-O-R-D. It is not called chord. It is called a chord, everybody. Chord. A segment where the endpoints are on the circle. Now, let's say that chord is special and that chord goes through your center. We could still call it a chord, but we got a better name for it. And that would be probably one you're familiar with, which would be the diameter. Yes, a diameter. Yes, a diameter. And fun fact, I don't know if anybody has lunch coming up or you don't have, who knows, but next time you see a friend, if you have one, diameter, longest chord in a circle. How about that? The longest chord in any circle is the diameter. And then we got the third piece, which is it's still a segment. One endpoint is on the circle, but the other endpoint is the center. It is not a chord. This is not going to be a type of chord like the diameter was. Instead, this is called you guys probably know this one too, no, maybe not. Radius, yes. A radius. Not a chord, because one endpoint is the center, not on the circle. And quickly, what's the relationship between radius and chord, or radius and diameter? Diameter is equal to 2 times the radius, right? Diameter equals 2 times the radius. Familiar? Questions? I just threw 3 vocabulary terms at you already, and we haven't even gotten through the first page. Questions on these three parts of a circle. There's more. Whoo, baby, there's a lot more. All right, but we'll just stick with these three now. Oh, whoa, not ready yet. I forgot my triangle. I threw it away too early. Ready? This side plus this side plus this side would give me the what of the triangle? Perimeter. Woo! This side plus this side plus this side plus that side of the quadrilateral gives me its. Hi, I have no sides. I can't do the perimeter, I have no sides. So we don't call it perimeter anymore. And in fact, since it doesn't have sides, what we're going to find is the distance. The distance around the circle, we're not going to refer to it as a perimeter. We're going to refer to it as...
It came up.
Yeah, I saw it. Thanks. Yeah, I saw it. Great. It just wrecks everything. Now it's just ready to roll into the word circumference. And then I get this.
Slide left.
All right. Oh,
Slide
I'm,
right,
well, I'm
slide
going.
right, slide right.
I don't need to wait anymore.
Page curls. Pinwheels. Genie. Cube. Star. Buck. Sway. Clock.
You guys are pros at this now, huh? I know, there's 16 right there, so. I think this is all of them. All right, ready?
Is there like 16 people in our class?
I'm not doing this. I'm not doing this. Curtains.
You know we all have numbers, right? We can just like go by order
Pinwheels.
with numbers.
Shatter. I'm not doing this. Curl. Slide right. Slide left. Drop. Wipe. Star. Cubes. Genie. Clock. Swing. Book. Flip. Fade. All right, drop and Promethean person. Are we ready to go O for whatever still?
This time we're gonna get it.
You think so? You really got it? Yeah, let's motivate. Yeah. Let's think positively, right? All right, everyone to get their dream shattered. Ready? Drop or Promethean person. Ready? Oh, speaking of shatter, huh? Look at that, huh? Who had the shatter? All right. Maybe next time, kids. Maybe next time. All right, ready?
You don't want to do your whole like lineup again?
My whole what?
Your whole lineup just getting us back to circumference. You should go right in.
Yeah, I'm just going to get right into it. Yeah, you can't find the perimeter. You got to find the circumference. I'm all out of energy now. All right, I'll get back to it. Go to the last page in your packet, please. Last page in your packet. I want to introduce you to something that you're familiar with, but not from this year. All right, this is called a formula sheet. You probably are familiar with it from Algebra 1 last year. You got that formula sheet on your Regents exam. And the same thing goes for geometry and Regents. And in June, when we take it, you'll get that sheet. Why am I introducing it to you now? We don't have any use for it until right now, which is the circumference formula is given on that sheet. You see the right left-hand side, it says one of them says circles. One of the two has the circumference formula. Why am I showing you this? Because any quiz we take now in this unit, I will provide a formula sheet so you don't have to memorize that formula. All right, why am I going to have you memorize it when you're going to get it for the Regents anyway? All right, so you will have access to that formula. There's two versions. I'd like you to pick what you're going to be most comfortable with. All right, there's C equals pi d, and if you choose to use that version, just know that d represents a vocabulary term we just talked about, diameter length, yep. And if you choose to use the second form, r would be equal to the radius length. As far as our notes go in this class, I'm going to use pi d all the time. All right, but if you want to use 2 pi r, feel free. All right, but I am going to use pi d every circumference question we have. All right, we're ready. Let's do a basic one, and they get tougher as we move along. This is just a basic circle, center, and then I give you this little piece there. I don't know if we don't know what that is yet, but we'll find out. So circumference equals pi d. If I use that, d is for diameter length, but 16 is my what? That's a radius, so I do not want to plug 16 into this formula. So I'll double it and instead plug in 32. All right, I'm not done with this problem yet. There's a couple things I want to go over. First is on the calculators. The pi button is right above 9. Okay, so make sure you're aware of that. The pi button's right above 9. I don't need it, though, for this problem. Please pay attention to the directions, and these are going to come up more frequently now, these directions. Leave your answer in terms of pi, which means I want to see the pi in your answer. All right, I don't want to see whatever 32 times pi is. I want to leave pi in your answer like it is right now. So this would be an acceptable answer in terms of pi. I have a little issue with it being the math guy. Do we say x4 or 4x in here? We say 4x, right? So you'll see me leave this with the pi at the end, 32 pi. Pi 32 doesn't sound right to me. It is correct, but. So the circumference, 32 pi. Again, when we ask to leave your answer in terms of pi, pi is in your answer. All right, do not go to the calculator. All right, so just finding circumference basic. Let's up the challenge now. Now I want the diameter and radius of this circle if you know the circumference already. All right, so we know the circumference, 106.4. I want to find the diameter or radius. Again, I'm going to use pi d for our notes. Where's that 106.4 getting substituted in for? 106.4, where are we substituting that in for? 5. Haley, where are we substituting in for?
C.
C, good job. 106.4 equals pi times d. Everyone keep in mind, pi is not a variable. It is an actual number. All right, so the only variable up here is d. And how am I going to get it by itself? Because they're asking me to solve for d. How do I get the diameter by itself here? 9, Ian. How do you want to get the d by itself? Yep, divide both sides by pi. Notice I do have actual rounding directions, nearest hundredth. So now I want to go to my calculator and use my pi button, which I'll do with you. 106.4 divided by, there's the pi. And now I round around to the nearest hundredth. 33.87. That wasn't the only thing I was responsible for. Now I got to find the radius. What do you want to do with this diameter to find the radius? Amy?
Divided by 2.
Okay, when we say it by 2, there's a certain it I want you to divide by 2, and it's not that one. To get the most exact answer, make sure we divide the unrounded answer by 2. All right, that's going to get us the most exact answer. So take your unrounded answer, divide it by 2 to get your radius. 16.93. Or if you have radius and you need diameter, multiply the unrounded answer by 2. All right, we good? Oh, I love this next question. Now I'm going to get fired up again. All right, we got a square, side length of 9. Oh, there's a vocabulary term we haven't talked about in ages. What's it mean to be inscribed? Encircle J. All right, so it looks like we got a circle. Where am I going to put J in the circle? Circle J. Center. Got it. So center J. And then I got a square too. I'm in, right? I got a square going on. Where do I put the square? Inscribe in circle J. Where's this square going to go? Inside the circle. Just not inside, but all 4 vertices have to be touching the circle. Right? So inscribe means the figure is inside. So the square, here we go, is inside circle J with all 4 vertices touching the circle. And each side of that square is 9 inches. And we are asked to find the exact, all right, real quickly, exact circumference. That's the same way I can also ask in terms of pi. All right, the exact in terms of pi. No long decimals, in terms of pi for exact circumference. Remind me of the formula we're using again. Circumference equals. Yep. So the only thing I only need to find what value? Diameter. What is the diameter of circle J? Is it 9, by the way? No, that's a chord. Not a diameter, that's a chord. All right, so I'm going to do this. Maybe you guys can help me out. Don't do it on your own paper, though. All right, diameter. All right, it's a chord that goes through the center. There's a diameter. If I can find that length, I can plug it in, and I got the circumference. Okay, how can I find that length? We know this part is how long? 9, right? But I got a little extra here. I don't know how I'm going to find that extra because it's not 9. All right, that's not going to work. Back to the drawing board. Oh, how about there's other diameters I can draw in. How about this one? Right there. I can draw that diameter. Okay, how do I find that length? Well, I know how long is this piece right here? This piece here, also 9, right? But again, I still got that little extra overhang. I don't know. All right, I'm getting frustrated. Maybe you guys can help me out. I'm 0 for 2 right now drawing diameters. Is there a darn diameter I can draw in there that I actually can find the length of? Because I'm 0 for 2. Is there a diameter you can draw in my diagram where it's like, you know what? I think I know how to find the length of that one. Matt, you better use your big boy words.
Diagonal.
Of what?
Square.
Okay, everyone agree. The diagonal of the square is equal to the diameter of circle J. Yes. All right. So let me draw that one in. We have a plan. I get excited. We have a plan. I know, Matt's saying we can find it. How are we finding that? How do we find that length? Zeev? Whoa. I was pretty good at Unit 8. I was pretty good at that unit. And I learned in that unit, you can't use Pythagorean theorem unless you have a right triangle. Thank you. I'm trying to get you guys to use your facts to prove this stuff to me. Good. Now we can use Pythagoras. There we go. A squared plus B squared equals C squared. This hypotenuse, this diagonal will be the same as the diameter. Where do the 9s go? Because all sides in a square are equal. Where are these 9s going to go? Should we go? Where am I going? It's just totally lost it there. Go on, refocus. Thomas, where's A, B, C? Where are the 9s going? A and B, good. 9 squared plus 9 squared is equal to C squared. 81 and 81. Don't take the square root till the end. Right now, 162 equals C squared. All right, let's take the square root of both sides. Everyone hits up their calculator. Takes the square root of 162. All right, you decide. You want to write 9 radical 2 or you want to write all that hot garbage right there? All right, it's up to you. I prefer 9 radical 2, but if you want to write the whole decimal out, you can. Hypotenuse, diagonal, diameter. That number represents 3 different things, in one problem. And I'm probably the only one excited and amazed by that, as I can tell from your faces. All right. Diameter. That's completely acceptable. That's in terms of pi, right? That's completely acceptable. If you want to change it, 9 radical 2 pi. Just please make sure the pi is clearly out of the radical. And you guys know, I don't know if I've talked about this, but I don't care about units. I don't. It's not a battle I want to fight. You want to put inches on there, go ahead. You want to leave them off, it's fine. It's not a battle I want to fight. How about that problem? That was good, huh? How do I get the diameter? Great discussion by everyone. Great discussion. If you thought that was good, wait till the next one. Wow, now the hype is going to get out of control with this one. Probably not for you, but for me. Circle Q, there's the coordinates of the center. And then I'm going to give you a second coordinate R. That's a coordinate the circle goes through, passes through. And I'm looking for the length of the diameter. Oh, let's go. All right, let's see what I gave. I guess I gave you a graph, so probably we should graph, huh? There's Q. Again, Q is the center of the circle. R is a point the circle goes through. Do we know what we're looking at right now? Before we even talk about the length of the diameter, I'm not even talking about that. Do we know what we've been given here? If you need a little more of a visual, here you go. Ready? I'll just take my super compass here. And I don't want you to get a compass out. Please don't. I'm just showing you. Let's see. Do you know what I just gave you in Q and R? Here's what I just gave you. Here's your circle. What's Q to R? Radius length. I asked for the diameter, though. So can we find the radius length and do what to find the diameter? Double it. Yeah. So everyone sees our plan. Take my radius length and double it. Yeah. Yeah, we know it's coming. Before I do any doubling, how are you going to find that radius length? Come on. How are we going to find it? How are we going to find it? Yes. Distance formula. Come on. Just once. Anybody else? Distance formula. Just going to leave me hanging like usual.
Radical x.
No, I meant in celebration. I don't care if you know it or not. Oh, you're happy we're doing distance, Josh? Thank you. Thank you for humoring me. Oh, sure, Josh. Go ahead. Let's go. Square root. Come on. Don't even do this to me. We've got every single unit. I think we've used this.
Parentheses x2 minus x1 n parentheses squared plus y parentheses y2 minus y1 close parentheses then squared.
Great job. There you go. There you go. Made my day right there. So go ahead, find the distance of QR, and then we'll double it. And do not go on to the next problem. I still want to talk about this one because we are in honors. Playing with fire here. Playing with fire. Let's see. Distance of QR. Will? Yep, no problem. Let me know when you're ready. What do you say? Or you want me to pick a new number just so Haley gets picked? Thank you. 5. QR is 5. Should I even?
Yeah.
Yep.
Or should I just take this one?
I mean, if you're scared,
You know that. Come on. And then what do I do with the 5? God! I walked right into it. God. Despise all of you. God.
Page code. Slide left, slide right. Push, clock, drop. Pinwheels, genie.
I got rid of them too.
Slide left, slide right.
So I say we don't
Drop.
drop. I say we don't drop. That's it.
White.
Well, yeah, there's 16 and there's 16. Look. No.
Drop. Oh, we had it.
Is there a genie? Oh no, sorry.
Swing.
Fade.
Flip.
I think that's 16.
Curtains. Curtains. Swing. Swing. Fade. Flip. Cube. I'm sorry, you want to flip? Haley?
Oh, no.
Cube. White. Book. Curl. Star. Shatter. Drop. Can't vote twice. Slide left. Pinwheel. Genie. Clock. Slide right.
Bro.
Oh my god.
Slide right it is. Slide right it is. Slide right along with the Promethean person. Again, second time this class. Going for no homework.
This time, trust. It's gonna be this. Let's go!
Wow. My own ego getting in the way. Finally, huh? Finally, it happened. That doesn't mean we're done with the notes, though. Finally, congratulations. It happened. I was really hoping you guys would go all year. And it's my own doing, too. I should have just wrote in 10, but nope. Had to put my ego ahead. Hey, Matt, what is the diameter here? 10, yeah. Good job. 10. All right.
It's an interesting video.
It does, yeah. Whoever's watching it. Imagine if you're in third period, you're like, what the heck? Got to do my homework. No? So. All right. Didn't have that one either. Spin. Spin. All right, final. Let's
That
finish.
one's never been shown.
No, don't. No, I'm not going. No, no shot. No shot. Last one. We've definitely seen the spin.
No.
Please.
Wait, is there not?
I'm not going.
16?
I'm not
17?
sitting there at my desk 8th period for another half hour
Wait,
finding where we had
Is there
spin
16
before.
And there were 16 up there.
I don't know how many there are.
Go count. Alright, let's see.
Let's see. What do I have? Tools. Where's page turn effects? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How's there 15?
You like missed the.
Well, this is none, and that's
Yeah,
random.
but, like, when you counted it, it like started like half, like two of them.
1, 2. I can't make this any bigger. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's 17 of them.
You're like adding them as you go.
I don't know what to tell you. You got no homework and we're still complaining. We have no homework and you're still complaining. Find the circumference, leave it in terms of pi. Let's go. Ruined my whole day now. Thanks. Ruined the whole day.
It made mine.
I'm sure. Ruined my whole day. I really wanted this misery to continue. Hopefully you're using Pythag to find the diameter length of 10. And if I'm leaving my answer in terms of pi, 10 pi inches.